Okay, everybody, thanks a lot for coming out tonight. This is actually a pretty good poll. So awesome. I think there's one other organizer with me tonight. If there are any others that I didn't see that came in. This is our first speaker event, I think in the meetup group history for like last 4 years, 2 years. So we're definitely looking for feedback from all of you on the experience today, as possibly here in the future. So the level of skill involved in getting to understand the future talks, maybe suggestions for workshops and so on. So please give those to us after or message us. Tonight we've got a pretty good event. Unfortunately, Brian Carvalho from Dockyard is not going to be here, but he's going to be doing additional, it's going to be a big face. I'd like to pull in somebody from architecture, architecture to introduce the location map. You're saying is that for both the pizza and the drinks.
Appreciate you guys coming. I think it's great to expose the community to the association space and what that area is doing. So this is the American Institute of Architects. We represent the profession of architecture and advocate for our members in the design community, which is the overall architecture engineering construction community, and we push the impact design has on communities to people in relevancy of design at the forefront of all structures, whether it be level or at the residential buildings to application. So that's our mission as an organization. We did embark on a project about 2 years ago where we said, how do we actually change the community? How do we make the community does more relevant to the larger ABC space and to consumers? So we actually started out thinking, how do we change the dynamic of what does it mean to have different users and we went through the process of training or retraining ourselves under the concept of agile, but really thinking about what does it mean for a user stakeholder requirement to be part about something we're actually doing? How do you separate that from organizational need and industry need? How do you prioritize it? So a lot of work went into us actually thinking differently about how we actually deliver services, which led us to there's new technologies available, there's new frameworks available, there's new platforms available for us to be successful in using the rapid and limited, which led us to have a new. So I'm actually supporting it. So I think it's we have some developers here who are within the organization that actually are developing a number and have resources from the report team, from the price that they work on developing some of the new functionality for
and also, David, you've got you've got some Ember, some awesome stuff.
So, how many people are familiar with Thompson? Yeah. So, DC has lacked the Thompson. Well, so as of last week, we had our own Thompson. Worked with the folks at Tilda to get Thompson together, and I asked them to take me. I was great, but we're not going to do anything until Thursday when they arrive. So I work for RSA, and we sponsored the sticker together. I'm going to get the artwork out on the meetup group, so you can get the cool DC guy as the logo. I have some you guys want to.
Okay, thanks a lot. Further ado,
Yep. So I guess everyone here, can you hear me in the back? Yeah. I've been told I mumble when I talk. Everyone familiar with Ember? Yeah. Firebase? Anyone use Firebase? Okay, cool. What do most people here do for backend? Rails? Anyone? Node? Node? Yeah. .NET? .NET? Anyone? No? Okay. Cool. All right. So, I mean, I guess I'm a full stack developer, but the last 4 years I've been doing just front end. Firebase is an entire kind of you could say platform as a service. So it gives you, and I'll explain some of this. I only have half an hour, so I'm going to speed through it. It was acquired by Google, so it's now backed by Google. I don't know if that's a good thing or not. But it's a real-time database, so it gives you a full back end. You never have to write any Java code or any server code. You just do Ember. Comes with file storage. You can host your application, your Ember app, for free. It has built-in authentication. You can add login with like one line of code. You can log in with Google, Facebook, GitHub, Twitter. I can show you some of this. No server code. Everything is free. It's cross-platform, and it has really good libraries for React, Ember, Angular, iOS, Android. Very well documented as well. Ember+Fire is the adapter that you use in Ember to talk to Firebase. So you don't have to write any custom code. You just use Ember data the way you use Ember data. Everyone use Ember data? I guess most people. Okay. The adapter is also officially supported by Firebase or Google. It's well documented, very easy to use. And getting started is very straightforward. You create an app at the Firebase portal. It's a couple of clicks to give it a name, and then you create your new Ember app. You install the adapter with Ember install Ember+Fire. You install the Firebase CLI, and that's pretty much it. When you start, you build your Ember app without writing any backend code. And I'll show you that. And deployment, you build the Ember app, and you just say Firebase deploy, and it deploys the entire dist folder to Firebase, and you can have it mapped to a custom domain. So free hosting, custom domain, everything. Wow, okay, that went way faster than I expected. All right, so we'll do a demo. So this is a brand new app that I just created a few minutes ago. All I did, actually, you can probably see my history. Let's see here. I started with I did Ember new Fire. So I created a new Ember app basically, and then I installed the adapter. Ember installed Ember+Fire, and well, let's go to step one. Step one was I created the app in the Firebase console, and when you create it, you go in here and say you want to set it up in a web app, and it gives you kind of your API keys and a couple of settings. You copy and paste that in your environment file. So that tells it how to talk to the backend. That's the only thing you do other than install the adapter. Then you create your models the same way you do with Ember generate model. So I created a simple model with 2 attributes. I created actually that's the only thing I created, and in my application template. In my app template, I added input box, with an add action, and then I loop over my my to-dos and display them on the screen. Now, if you look at the routes, I should slow down because I have half an hour, right? The route, nothing special, just regular Ember data stuff. Restore, find all. So as you can see, nothing special to Firebase. You're just building an Ember app. And in the controller, I have 2 actions. One is to add my to-do. Again, just regular Ember data. Create the records, and then you hit save. And you call save. And then I just added a little code to toggle the done checkbox. I just toggle done and I save. And this is what you end up with. Here's the input, test, add, two. Now, this is actually persisted in the Firebase database. So if I go in here, you can see these are the two to-dos that I created. Now, here's the cool part about Firebase, is the real-time aspect of it. So if I create a new window here, so this is a completely different session, incognito. And then I go to the same URL. And now I'm seeing the same data. So let's say I create a new one from here, add, and it updates on the left. I mean, I know it doesn't look like much, but I didn't write any code. And that's the beauty of this. It's magic. it's using WebSockets, yeah. But they have their own. I think they have their some kind of compression algorithm, so it's very efficient, and it scales very well. So again, I can check something here, and I'll check it on the left, check it on the right. Deploying it is very easy. So if I do Ember build production, in a few seconds. So here's the other cool thing. If I go into the database and actually directly change stuff in the database, it updates on all the clients as well. So the database console itself is like a WebSocket client. While it's building, let me show you something with the authentication. And I can show you a different app that I have that has all this built in. Turning on Google authentication is a checkbox, and you have Google authentication. This is actually one app that I'm working on right now. So if I show you guys this, let's see, it's still in beta. So we'll do login. So I turned on Google authentication, Facebook, Twitter, GitHub, and there's like 1 or 2 lines of code that I put in here, and I have authentication built in using Firebase. Again, without writing any server-side code, which is great. You can log in with any of the accounts. You can link accounts to your profile. But I'll come back to that. Let me show you the deployment. So it built the application, and then Firebase. You do this once to kind of link your app to the Firebase app. I forgot to do it before the demo, so go ahead and do it now. And it just asks you a few questions. And it asks you which app you want to link this to. And then you just do Firebase deploy. So anyone with a computer can actually go there right now. Go to this link. Let's see. If you go to this link and start adding stuff, everybody will be synchronized in real time. So that's how easy it is to deploy. Any questions? Yeah. It doesn't. Yes and no. So what you end up doing is you create multiple apps in Firebase. Like you do your dash production, dash dev, and then you can use a configuration setting in your Ember build and have it target different databases. I actually do that in that application I was showing you, Hire.js. So if oh, another thing Firebase has that's very cool. It has storage, file storage, so you don't have to deal with AWS. It's all built in here. And so, for example, when you go to Hire.js and go to file, you can see I can upload a resume. Let's do. So I just uploaded the resume here. And you can download it. Again, no server code, so it's pretty cool. Now, so a big thing with Firebase is how does it know who has access to write to the database? And it does that with rules. If you go under database, you go under rules, you get to configure what each. So if you guys look at the database here, for example, I have these. Each one of this corresponds to an Ember model. So I have a profile model, I have a skill, and then you can have your has many and belongs to relationships. It all works. But for example, you don't want user A to edit the profile of user B. So the way you do that, you define it in rules. So if you look at, say, for profile, and this is very well documented. You can tell it that these are the rules that you need to validate before you write the data, and and it checks your user ID. It makes sure it matches the user ID that corresponds to that profile. So it does that. Again, you just have to figure out. You have to understand the syntax, and that's pretty much it for implementing security. The cool thing is you don't have to edit it here. It's there's a file called database rules in your Ember app. So you edit that when you do Firebase deploy, that gets deployed. So it's source controlled. You can make the changes on the machine and then deploy it. You definitely don't want to do this in a production because you just say read and write anything. So anyone can go into the Chrome console and delete your data. Let's see what else. Any questions? Yeah. I'm glad you asked that because I'm running out of stuff to say. So, yeah, you can turn on email password as one of the authentication methods. So when you do that, it gives you out of the box password reset. I forgot my password, all that stuff built in. And I can actually show you some sample code. Another feature that I really like is anonymous users. So I have that turned on in Hire.js. So the first time you hit the site, you're actually authenticated, but anonymously. And the reason I do that because I want people to come here and say they want to post a job. In the Ember data, the Ember model has a user relationship, so it needs a user. So I tie it to the anonymous user, and if you sign up, I convert the anonymous user to the authenticated user. And I can show you some of the sample code that I have.
left it?
That's a good question. You have to. I mean, you don't have to, but I think they last for 30 days. It's just a cookie. But yeah, it gets messy. So one thing, obviously, since there is no server, there's certain things you have to do on the server. So if you want to process, say, Stripe payments, you can't do it from the client. If you want to send emails, transactional emails. So, someone applies to a job on your site, you want to notify send an email and notification email. You can't do that. So Firebase doesn't have a server-side code, but it's actually very easy to do. So the way I did it is I created a Node application, and it's pretty straightforward. So one thing I do, I'll show you here that as an example, when someone signs up, I want to take their email address and put it in MailChimp, subscribe it, so I can spam them later. So what I do here is, this is Node.js. So I basically tell it to look for a property called added to MailChimp, and if it doesn't exist, equal to null, I want you to run this function, this method here on line 27. And what this does, it gets out the email, it does some stuff, and then it calls, the MailChimp API, and then it sets the flag to true, so it doesn't get fired the next time. And then I deploy this to like a DigitalOcean, machine, VM, and I just have it run using Forever or Node Forever, I think, and it just keeps running. So because the database is real time, every time a user signs up, it triggers that function in real time. And then I do that for billing as well. So I look at a certain flag in the database, and I say if it doesn't exist, go ahead and process the Stripe payment, and I run the Stripe code using my API key. So that's how you kind of get around not having a server. I'm not calling it. It's using the WebSocket. So the same way it updates the browser, it's updating. It's like I guess underneath it, it's a WebSocket callback. So just listening to that event, and you can add filters and queries. So you say, I want to listen to, I don't know, React developers, so I can, I don't know, spam them send them extra emails or something like that. Exactly, yeah. Yeah, I mean, you can, a lot of the stuff in Firebase, you can do with, I think PubNub or PubSub, it's another service. There's a couple more that do that. There was Skinvey, I think. But I played around with several of those platforms as a service, and I ended up with Firebase. And I used them before Google bought them, and now that, they have the backing of Google, I think they'll be around for a while. No, it's using, I actually haven't looked, it's open source, but I haven't looked at it. But it's using sockets, WebSockets. No, you don't. You just do the model.save, but I can show you if you look into here. If you go, yeah. So that's the thing about the protocol. It's very efficient, and I think it does a lot of deltas. It's not sending everything, but you can see some of it here. It's hard to read, but you can kind of figure out most of it. If you go into Let's see, I think here. So you can see that's the data coming, coming and going. So if I do an update, see it's sending the model using some kind of format. But I mean, it looks like it's just JSON. And on top of free hosting, free database, free file storage, you also get free HTTPS. So yeah, I mean, nothing is really free, but the limits are pretty good. I mean, I've created several apps and haven't hit the limit. That's probably because the apps are not very successful. But it's still very affordable. So if you look at the pricing, it's very reasonable until Google decides to shut it down. But yeah, so for free, you're getting a good amount of stuff. Yeah. Test.
Hello. There we go. Yep, we can hear you. So you'll have to mute your site because I hear myself talking back. Actually, no, that's better now that the other one dropped. Okay. Hello. Oh, maybe not. Now I just did an echo. Yep, we can hear you. So what I'll do is, let me try to start the screen share right now. It will be a little bit tricky with because you're muted on your side without me getting the feedback. So if anyone has questions, if they could just leave them to the end, and then we can try to do unmute at that point. And you'll have to give me the signal on when we're ready to go. Hello. Steve, can you hear me? Do you see my screen? Cool. Yeah, I think because you're using the external speakers, the noise cancellation doesn't work properly. So it'll just keep going and going and going and going. Out of curiosity, Steve, can you
turn your camera on and pointing at the audience just so it doesn't feel like I'm talking into a cave. You can keep it muted, but I just want to see human life.
I actually had the YouTube video playing at the same time. Yeah,
Okay.
so this is all my fault.
Yeah, it sounds a lot better now.
I'm gonna put you back on the big speaker though. I'm sure that'll be fine. I hope to God. Output, big speaker. All right, can you speak?
Hello? I'm just going to hear myself talk. So what you can do is you can just announce me with yours unmuted. And then as soon as you're done announcing me,
I'm gonna mute it now, and then I'll let you know when to go.
Can you turn your camera on and just point it at the audience? I just don't want to see nothing. I'm looking at Steve. Audience of 1.
Brian, can you show us your face for 1 second, and then I'll give you the go?
My beautiful face. Okay, hold on.
Come on, give it to us.
I know, I got to stop the screen share. Hold on. Hello, everybody.
Great. So Brian's CEO of Dockyard, a creative design and development consultancy up in Boston. So Brian had something he had to take care of today, so unfortunately couldn't be in here. However, Brian's going to be able to give us a pretty good overview of progressive web app development. So I think that's as much as I can say about you, Brian. You can go ahead.
Unmuted. Okay, hold on. I'm getting there. Okay, progressive web apps. So this is a little bit of a joke about progressive web apps. The dinosaurs are dying. If you're used to Chrome, then you'll be familiar with this joke. If you go into offline mode, you see the little dinosaur game. However, as an aside, Googling for dead dinosaur is actually pretty depressing, even though none of these were accurate or real in any way whatsoever. So don't Google for dead dinosaur. For those of you unfamiliar with what I'm talking about, this is it right here. When in Google Chrome, your internet connection drops, this little screen will pop up. If you press the space bar or up or whatever type of key allows you to jump, it'll actually start an interactive game. And the game will continue until you die and start over again, or you can your internet connection comes back, and then the page you're attempting to get to will load. My high score is somewhere in the thousands. So all this to say that this game was created as kind of a pain relief for those that are dealing with offline mode in their applications. And what I will do, because I actually can't see my screen, I can't see if Steve's if there's anything going wrong. Steve, if there is anything wrong with my my feed or my my slide deck, or you can't see or hear me, just text me and I'll get it on my phone. We can try to correct it. All right. So as Steve said, I'm the CEO of Dockyard. This is me after winning an award a few years ago. I wasn't expecting to win, and so we had a good time, and then we surprisingly won the award. I wore it around my neck for the rest of the night. We're a design and software engineering consultancy. I hope that some people in the room have heard of us before. We are a shop that focuses very heavily on Ember.js development. We've been very involved with the Ember.js community for the past 5 years or so. We've had Ember.js core team members in-house. We nearly all of our engineers have made significant contributions back to the Ember back to the Ember framework. We have many add-ons that I hope that people in the audience are using and enjoying. We also blog quite a bit about Ember.js. We run a conference in Boston called Wiki Good Ember that was this past June, and we are actually running a second conference in San Diego late January called So Ember. So if we are expanding to San Diego, and this is kind of our little bit of a coming out party in that direction. You can go to soember.com and read about the details. Early bird tickets, I believe, go on sale on Monday. And Luke Amelia, the CTO of Yap, is our keynote speaker. All right, so the mobile web. The big question people have about the mobile web is, who cares? Who cares about the mobile web? It has been kind of this throwaway for a few years now. In fact, native has been kicking the butt of the web on mobile since the iPhone came out. But I'll tell you who should care. First of all, you should care. Your boss should care. Anybody at your company that's responsible for the company making money should care about the web on mobile. So if we have to care about the web on mobile, how strong is native? What is native's position, and what do the numbers actually show? And can these numbers help create a story for us to sell progressive web apps and mobile web within our own organization? So as a little bit as an aside, there is going to be some technical side of this towards the end, but this slide deck is really meant to help build a business case for progressive web apps and mobile web. A few months ago, I think this was TechCrunch, put out an article that is tearing up Twitter for a few days. Nearly 25% of people abandon mobile apps after only one use. Oh my God. The interesting statistic is that this number really hasn't changed for the past 4 or 5 years. So since 2012, at least when Localytics was tracking data, the application abandonment rate has been around like low 20s, peaking at 25% in 2015. However, that the application abandonment rate has hovered between low 20s to mid 20s isn't the interesting part. The interesting part is that based upon some other numbers that affect this directly, you can draw a conclusion that this is not a sustainable business model. Let's see why. In 2012, the acquisition cost per user on native mobile was $1.50 compared to $2.25. Up until 2015, these numbers almost doubled. So for an application abandonment rate that has hovered, between 22 to 25%, the cost of each user to acquire them to still hit a 75% user acquisition rate, application acquisition rate, is costing you double compared to what it was in 2012. In fact, it's costing you a lot of money. There's many cases in which the development of the application is not the major cost of releasing an application on native. In many cases, it's actually the marketing. In order to have an effective application, unless you are a top tier producer or you get lucky and for whatever reason it just goes viral. In most cases, the viralness of an application release is due to some very heavily and costly marketing. But in either case, you're likely going to have to pay out the nose in order to move up the ranks. If you're unfamiliar with Fred Wilson, he's the lead at Union Square Ventures, commonly thought of as a thought leader amongst a thought leader's thought leader, if that's a term. So Union Square Ventures, of course, is a venture capitalist firm, and last year he had this quote: "It's not an easy time to build consumer-facing mobile companies. It's not an easy time to invest in them either." So VCs are starting to get wise to the native mobile game. Around this time last year, Alex Austin posted an article on called "Mobile App Developers Are Suffering." The TLDR of this article is that adoption barrier is too high. He cites the App Store's discoverability problem, cracking the top 10 is nearly impossible and too costly. If you can crack the top 10, if you cannot crack the top 10, you might as well not even exist. I think that the App Store is starting to address this a little bit. When we talk about App Store, we're primarily talking about iOS. iOS represents nearly 50% of mobile traffic and represents a vast majority of application use, native application use on mobile, especially amongst those that are driving revenue. So all this to say, if we're faced with the reality that it's becoming prohibitively expensive to produce native applications, where do we go? At Dockyard, we built the company around the idea that we want to push the web. We've had the option and the opportunity to chase native at certain times, but our strategy has always been to push forward the web. We believe in it at the cost of a lot of business. So there are several over the past years contracts that we've lost specifically because we don't offer native. And I'm sure that there are other consultants in the room that may have similar stories. And there's probably a lot of product developers in the room that have sat inside product development meetings at your companies, just listening to somebody that had the argument that we need to be in the App Store without actually delivering any real reason for being there. So hopefully some of the numbers that we're going to be talking about, some of the numbers I already talked about, can help you and arm you to go back into these conversations and say, hey, you know what, we have a pretty good financial argument here for perhaps not going native. So all that to say that if native is not the answer, or native is becoming prohibitively too expensive, there is another way. Let me introduce it to you. It's called the internet. It's called the web. This crazy idea has billions of built-in users. So built-in user base is always very interesting for people to hear about. It has this amazing discoverability engine. You just type in anything, it will find it for you. And it is completely distributed around the planet. We don't have to actually pay for distribution of anything, at least to a certain degree. Distribution costs are essentially nil in most cases. Now, does that sound like something you might be interested in? All this is great. However, we have to accept the fact that UX on mobile for web has sucked. The reasons for this are no home screen apps. Now, WebKit, mobile WebKit has had the option to save the home screen, and there was the bundling of applications, but that was a complete misfire. It didn't work very well. Its caching layer had a lot of security problems, and it wasn't well supported amongst all the browser vendors. No offline mode support. Google attempted to solve this problem a few years ago, and it failed miserably. So without offline mode support, the web is not an option for many use cases. Furthermore, in areas that do not have good connectivity, mobile connectivity, it becomes effectively useless. If you constantly have to go out and fetch new assets, if you cannot if you cannot be in an offline state in your application and still be productive in that application and have it sync up later when connectivity is restored. So this is a problem that has to be solved on the mobile web. It's incredibly slow. There are many reasons why mobile web is much slower on mobile than native. First of which is that every single time you go and visit the web page is effectively the same of having to go and reinstall the application on every single visit. Imagine if every time you wanted to use like the Twitter app, the Twitter native app, that you had to go and reinstall it on your phone every single time you wanted to open it up. That's effectively what's happening. Every time you visit a web page, it's going through a quote unquote installation process because all the assets are being downloaded. Native gets to cheat in this regard because they incur the one-time cost. And they also get to cheat in this regard because their one-time cost is significantly higher than the web's multi-time cost. So a lot of people they click install. If you've looked at the actual footprint of a native application, many of them are 50 to 100 megabytes in size. Imagine if anybody actually had to try to create a mobile web app that had 50 to 100 megabytes of assets. You'd be laughed out of the room. Typically, web developers are held accountable if we go over a megabyte in asset file size. And Ember itself is actually knocked down because it's considered to be a quote unquote fat framework. These are problems that are being solved. Part of what LinkedIn is currently working on for the Ember engine story is, and there's a lot of devs at LinkedIn that are doing some really good work for Ember CLI. So part of that effort is working on the tree shaking story. Tree shaking will allow the module dependency tree to be walked, and anything that you are not including in your application will not be consumed into the final asset footprint. So that includes your add-ons, includes vendor stuff, anything that you're shim supporting, and also includes Ember itself and Ember data. So imagine you are in a world where perhaps you're not making use of Ember array, for example. Probably not a reasonable function of it, but just for example, if you're not using that function anyway in your application, the module dependency tree will be walked and it'll say, hey, we're not using this, so we're not going to include it in the final build. So we hope to see sometime in the next year or two, which sounds like it's a far time away because I know everything moves very fast in the JS world, but we hope to see soon enough tree shaking, which would be really, really good. Furthermore, engines will also allow us to opt into lazy loading. So if you are producing add-ons right now, for example, I have an add-on called Ember Admin. Ember Admin allows you to add in some basic CRUD-like functionality into your app that will set up some model creation, editing, viewing, etc., deletion functionality to give you like a very basic bare bones admin backend. You currently have to incur the cost of including this add-on and all the assets inside your footprint. With Ember engines, where they're going to be is that the routes themselves will be lazily loaded, all the assets associated with it. So if you had /admin, you hit this, your Ember CLI application will then respond with the admin assets. And this will be wrapped in a promise, so the route itself won't resolve until the promise resolves, which means it's going out and fetching those assets. So that will be really nice for reducing asset footprint, which should also speed up the application quote unquote installation time. So all this, those three things lead to what I call the triple facepalm, which is not fantastic, right? So this is like, oh my God, like mobile web, how have you failed us so hard? Well, if we could solve these issues, if we can present a way in which these problems are no longer problems anymore, that would be fantastic, because now we can produce applications that are as good, if not better, than native, and we can stay with our single technology stack. We don't have to have separate teams. We don't have to rely upon outside consultancies to actually manage the Android stack and manage the iOS stack. You can use your existing web application team to also manage your mobile web application team. These are very good reasons for companies to start being interested in progressive web apps. All right, so what is a progressive web app? What are some of the features? Instant loading. Allows your app to load nearly instantly and reliably upon repeat visits. This is accomplished through API I'm going to show a little bit later called the service worker. So the service worker will allow you to cache assets. So the first time you ever go and visit the web page, you're going to incur the cost of downloading those assets. That will be the acceptable quote unquote installation cost, right? Depending upon how you want to structure your progressive web app, you will be able to selectively decide which assets are going to be cached locally and which ones aren't. You can also decide which like what the cache busting strategy is, like when the cache will die out and go and attempt to fetch an updated version. So if you could say, hey, all these images and our application shell and some stuff, some basic stuff, these are like vendor.js, for example. These are not subject to going out and fetching the next time. If you have a basic enough application, then perhaps you want to cache all that stuff, but you want to get the latest updates from your server. So the next time you go and visit, that stuff will load up from cache instantaneously, and then it will attempt to just go out and fetch some data. Fast. So fast is a matter of perception. And if the application loads fast, then we're going to have a fast experience. If now we actually probably, I made these slides a couple months ago, so it was more recent back then, but we no longer have, if you are setting your viewport size properly on WebKit, you no longer have to incur the, I think it was like 300 millisecond tap delay, which was, you know, really dragged down the user experience on mobile on iOS. On Android, I believe that this has been gone for at least over a year. And so you think about it, like the mobile web, it's still making network requests. And so that's not going to be any less fast than a native network request. If we get past this whole notion of having to download things all the time, download all these additional assets, then we're going to have a fast experience in our applications. And Ember is perfect for this, right? So you can create a progressive web app with a server rendered application. But then you're still going to incur the cost of every single page load of having to go out and fetch these new assets, unless you are preemptively, setting some crazy app cache, asset list to prefetch. With Ember, we have this application that's in memory, and we don't incur an additional fetch for a whole page on every single link. So progressive web apps, the caching, the offline mode, plus an Ember-based application can result in a very, very fast experience, which is fantastic. Sorry, you may hear my son in the background. He's attempting very hard to talk. All right, so offline mode, Li-Fi mode. Li-Fi is a term, as far as I know, was coined by Alex Russell on the Google Chrome team, who is one of the primary devs behind progressive web apps. And many of you may not know what it means, but I guarantee you everyone in the room has experienced it. Everyone should know what offline mode is. There's no internet connection whatsoever, no service, or you have your phone in airplane mode, right? Li-Fi mode is when you have bars on your screen and you're just not getting any data whatsoever. Your phone is lying to you. And this is, I would argue, more frustrating than offline mode. So progressive web apps, through its handling of offline mode, through its handling of slow connections, we're going to be able to accommodate for this and provide a much better user experience around it. So far on Android Chrome, if you go and visit so there are certain characteristics of what it will take for your browser to recognize if this is a progressive web app or not. And I'll get to some of the other ones, but anyway, if your browser, if the application makes a checklist, right, and says, okay, we recognize this as a progressive web app, it should then prompt you with a banner to say, hey, you've been here, I don't know, twice in the past day. This looks like an application you are very interested in. You can then choose to install to your home screen. At that point, you get the icon, you get a splash screen, and it will remove the Chrome, meaning kind of like the address bar at the top, some of the reload, forward back controls. And so from a consumer's perspective, it looks just like a native application. It feels like a native application because of all the performance enhancements we're getting around it, through caching, through handling of offline mode, etc. So adding to the home screen kind of completes the installation process. This will admittedly probably be the biggest hurdle and require the most education to users to get past. We've been trained for the past nearly 10 years to go to the App Store, to search for something, to click install, to wait a minute or two, or however long it takes to get the application. If you're not in a good network area, it's probably going to take a lot longer. So I think this will probably take a few years to really get into, especially we're talking about like the tail end, the non-early adopters and such. But in the end, we will have this experience of installing the application through a prompt coming up in the browser. Security. all progressive web apps have to be under HTTPS. So if you are producing a website or web application that meets all the other criteria of a progressive web app, it has service workers, it has, it's not throwing interstitial banners up saying install the native application, it's using offline mode, et cetera, but your application is not under SSL, then the browser will not recognize this as a progressive web app. So for many other reasons, primarily that Google does ding you now for not having your site under SSL. But for many other reasons, just because security is always good, you should strive to have your entire web experience under SSL. So this is something that will be a requirement if you want your application to be recognized as a progressive web app by the browser. Finally, not finally, but push notifications are something that is coming. I know that there are some of the mobile browsers out that are support some early APIs around this, but the goal of this is to offer a native-like experience for push notifications. So it's not web notifications. Web notifications API will actually have you inside the app. The push notifications will allow you to register with the native push notification system on your mobile device. At that time, your server can then push notifications to that device in the same way that notifications are pushed for native applications. That notification will be associated with the progressive web app. So if there is a, let's say you're building a sports information website, and I'm a Red Sox fan, so the Red Sox win a game, and I get a notification, and it says, "Hey, Red Sox win again. Click, check out the box score." When I click on that notification, it will automatically launch my progressive web app and bring me to the right part of it. Responsiveness, of course, is a huge win. That just isn't possible on native. I know that there are some solutions to supporting multiple screen sizes and some responsive type ideas around native, but a true responsive application should not just work across different device sizes. It should be cross-platform. So this is, right away, if we say to our boss and say, hey, we're doing pretty well right now, we should start thinking about the next 5 years. If we make the next 6 months this investment on our application, this is gonna pay off within the next 12 to 16 months, and then we're just gonna keep coming out ahead because of that, because we're not having to support development on all these other devices. We're not having to actually support the release of new operating system versions, and that's a big problem on native. I'll get to some data in a few minutes, but on native we have issues where because like on iOS, they can just drop and deprecate APIs at will, whatever they decide, even if they think it's a good idea about moving forward with a given API. The support cost, the maintenance cost, let's say you're feature complete. This application feature-wise is never going to change. You want to stay relevant on each iOS version, you're going to have to incur the cost of actually supporting each iOS version. For certain organizations that have more than one app, this can be incredibly expensive. Okay, all these things, they sound great. Again, who cares? Who cares about this? Can we actually see this in action? Thankfully, there are some case studies already out there that demonstrate the benefits of heading in this direction. Probably the most popular is Flipkart. In 2015, Flipkart, which is India's largest e-commerce site, they adopted an application-only strategy and temporarily shut down their mobile website, website. The company found it harder and harder to provide a user experience that was as fast and engaging as that on their mobile on their mobile app. But then Flipkart decided to rethink their development strategy. They were drawn back to the mobile web by the introduction of features that made the mobile web run instantly, work offline, and re-engage users. So some of the data points here. users' time on site with Flipkart versus previous native experience. So now with their progressive web app, users are spending 3.5 minutes inside their e-commerce site. Previously, they were spending 70 seconds on average. This results in a 3 times more time spent on site, which if you're trying to sell things, the more time your users are in your application, the more opportunity there is that they're going to, the higher the chance of them actually making a purchase. 40% higher re-engagement rate. Users came back 40% more often than with a native application. Conversion rate among those adding to the home screen increased by 70%. Data usage was 3 times lower. This is very important in countries like India or areas like India, regions where network connectivity is not a guarantee. If you have bad or not great network connectivity, then the less data that you need to send over in order to accomplish a purchase is going to result in a higher purchase rate. Next example, gov.uk. Some of you may have read this. This was actually pretty damning news that came out a few months ago. So Ben Terrett, the former head of design at GDS, which is Government Digital Services in the UK, said they banned all native application. Banned all native apps. The reason for that was the cost incurred to develop and maintain all these applications. You can imagine that the UK government had many different native applications. So when we're talking about native applications, we're not just talking about the applications that are in the App Store. These are public-facing commodities. And I'm sure that they had some that were used by citizens of the UK. However, there are private app stores. Large organizations, governments, they have private app stores where applications are built for internal use. So amongst all the applications that the UK government had to maintain, Ben Terrett said this: they are very expensive to produce, and they're very, very expensive to maintain because you have to keep updating them when there are software changes. And it's great that iOS comes out every single year, a new version, but that means a nightmare for companies and IT departments and developers that have to maintain these applications. I'm sure there are a lot of shops out there that welcome it because they know there's guaranteed work every single year. They get a phone call from their clients, hey, new version's out, we got to make sure that we're going to be working on it. But I don't find that to be a very compelling business model to me. I like the idea that the web, if you built something on the web 10, 15 years ago, it still works today. I mean, that some people look at that as a huge amount of technical debt, and perhaps they're true. But if you produce a mobile web application today, it's going to work 15 years from now. Your organization does not have to go through this seasonal adjustment, seasonal maintenance, seasonal refactor, upgrade, release. So the numbers, Government Digital Services in UK saved $8.2 billion over 4 years by taking this approach. And that's not a little bit of money, billions of dollars. Can't promise that your organization is going to save billions of dollars, but they could save thousands of dollars. They could save hundreds of thousands of dollars or millions of dollars, depending upon what your organization is. If you work for the US government, being in DC, who knows, maybe you can save billions of dollars. Conga. Launched in 2012, Conga is a leading e-commerce website in Nigeria. They sell everything from books to fridges to mobile phones. And mobile devices provide their largest source of traffic and user growth. Okay, let's look at some Conga numbers. 92% less data for initial load versus native app. This is the installation cost I was referring to. So all of their mobile web assets, 92% less in size than their native application assets. Of course, sometimes being in the United States, we are, I'll use the word privileged in the sense that we have good network connectivity and we got good Wi-Fi. We have good cell phone networks. So installing a 95 megabyte application, not a big deal. But if you're in Nigeria, perhaps it is a big deal. Perhaps it's going to take 15, 20 minutes, maybe an hour to download that application. If your mobile web application is 92% less in size, that automatically is going to translate into a much higher, or much reduced rather, application abandonment rate. 82% less data to complete the first transaction, first native application. It costs 82% less in network data for users to purchase something on the mobile application versus the native app. 63% less data for initial load versus previous mobile web experience. So when they moved over, they had both a native application and a regular mobile web experience. When they built out the progressive web app, the way in which they built out the progressive web app actually meant for a better mobile web experience than what they previously had. Actually meant for a reduced asset file size, because they knew that's what it was going to take, and that's what they had to focus on. And their data to complete first transaction was comparable to the native application difference between their previous mobile web experience. If you're interested in these case studies, there's a whole bunch of them. If you go to, I think, developers.google.com/web, I believe is the URL. Or if you just search Google developers, progressive web apps, there's a lot more up there. And you'll probably find something perhaps for your industry. I know I focused on e-commerce because it's such an easy thing to show, like the association between time and money. But Google's been tracking success stories. And if you need to go to your boss with some information, you can probably find something on the Google case study site to help arm you. Okay, this is great, but we want to talk about money. How does this work for you? We keep hearing this idea that mobile web is dying. And part of the reason that Google and the other browsers have pushed so fast and so hard on progressive web app is because they buy into it. But sometimes the data does not actually back up that claim. In fact, what we've seen over the past few years is that mobile web traffic is growing at a rate twice that of native application traffic. And when it comes time to making purchases, actually spending money, compared to time within the application, on native applications compared to web, 14% on web, 86% on native apps. But when we're talking about commercial tasks, between web and native drops down to 6%. The mix between sites and apps, there are some sites that will launch up a web page or something. That counts for almost 30% of traffic, but 66% of traffic on mobile is for commercial tasks is through the web. There is a UX story and UX lesson that we learned here is that despite Apple Pay, despite, I don't know what Android has, but what their equivalent of it is, people still prefer to make purchases over the web than they do in native. But how? How do we now provide this experience to our users? What are the tools and the APIs and such, this is the technical part of the talk, that we can use in order to build out this type of application? So I'm going to introduce a new API if you're unfamiliar with it. It's called the Service Worker. Service Worker is it's available in Chrome, it's available in Firefox, it's available in Opera, it's available on Edge, not Internet Explorer 11. And it's missing from Safari right now, but I'll talk about that in a little bit. And the Safari story is not as hopeless as some people assume it is. The way it works is that it basically sits between your web page and the remote server. So any network requests going out get sent through a service worker, and then any responses coming back get sent through that same service worker. So it allows you to capture and manipulate the request or do something with it, and it allows you to capture and manipulate or do something with it, the response from the server. That is, on a very high level, what the service worker provides to us. the life cycle of a service worker is that we can install it. If for whatever reason it's broken, or we do something wrong, or the server throws up, sorry, if the browser throws up, then we get an error, and we can handle that error appropriately. Otherwise, we get an event called activated. The service worker then goes into an idle state, and it's waiting to fetch and send messages to and from the server, remote server, or it's waiting on termination. So that is a pretty simple life cycle, but that is it for the service worker. And if you want to install a service worker, this is it. So we detect whether or not service worker is available in our browser. And then we just do navigator.serviceworker.register, and we pass it a local path to a file. You don't have to call it sw.js, but that just seems to be some of the convention that some people are using right now. And inside the service worker file, this is a completely separate JS file than your application JS. We can revert, the service worker is referred to as self, and we add the event listener install. And then we give a callback. And within that callback, we can now do some interesting things during installation. So for example, let's say we had some assets that we wanted to cache. So we may start with a predefined list of paths to some of these assets. And during the installation callback, we are calling this event.wait_until. This is just waiting until the event is available. And then caches, which we'll talk about in a minute, allows us to open up a named cache, and then we can call into that named cache and basically tell the cache we want to cache all the assets found at these given paths. The add all function will allow us to give it an array of paths. So there is two sides to the cache object. The first is on the class side, really, which you're not going to interact with much because you're likely to just get the prototype of the cache associated with your application. But this is the API for the class level side. And this is going to be the API on the we'll call it the instance or the prototype side. So if we want to match on a given request URL, we can pass it the URL, and then we're going to get the result of whatever stored at that key for that cache. We can match based upon either a request object or a request path. We can add, we can remove, we can the cache.put allows us to break up the request and response and put that in. And then the keys will give us back all of the keys for that given cache path. All right, so another part of the progressive web app experience is replacing XML HTTP requests. Now, short history on XML HTTP request is that this was a non-standard W3C spec API. It was added by Internet Explorer and kind of kicked off the whole, we'll call it Web 2.0 side of things. It eventually came in as part of the specification, but it was driven primarily by some needs that Microsoft had. One of the reasons why this fetch API is being introduced is because if you ever tried to create raw XML HTTP requests, it can be a little daunting. And furthermore, it is not promise-based. So the promises that we want to have promises wrapping all of our responses so that we can not have to work with callbacks all the time. We can just listen on these promises and use those appropriately. Anyway, all this to say that below is the, this is going to be an example XML HTTP requests that we would make, and we're just going to add an event listener on load. We're going to make a GET request on this URL, and then we're going to send that request. Okay. the fetch API is as simple as this. Done. We just give it the URL that we want to fetch from. If we give it no options, it's going to assume a GET request. Of course, you can get more complex with it, and you can build this out to your the way you want to. But it allows for this much simpler API, but also has the power to build a more complex request API. All right, so now to add a fetch event within your service worker, we're just going to add an event listener on fetch. So anytime now, if you're within Ember Data, you're doing Ember Data dot like get records. Sorry, if you're doing a record request with the Ember Data, anything that is going through the service worker will be automatically interrupted. Right. So this here is going to respond with this fetch event request response. All right, so Steve says I have 10 minutes left. I'm getting close to the end. I'll be good. And sorry, Steve, your text message threw me off. All right. Oh, okay. All right. So this is a very basic respond with, and this is just a pass through. So this will not do any caching. This will just say any requests that we get that we're capturing, we're going to just pass off to the backend automatically. This is a little bit more complex here. So what this is going to do is say, okay, so for this given request method, if it's not equal to a get, so if it's like a post, delete, a put, a patch, or options, we're just going to pass through. We're going to pass it through the server because we don't want to cache those requests. We don't want to cache those responses, but we do want to cache the get responses. So anything that is a get request will now fall through to this handle other requests. And we can see how we can implement this right here. So we're going to say respond with, and then we're going to cache the matching request, and then respond with query cache. But what is query cache? That's going to be another function. Query cached can be, this may look a little bit complex, but I'll distill it down because it's not that scary. Okay, so what ends up happening here is that the cached request object comes in, and then we attempt to fetch it. It'll do network first. So if the network, if fetch from network worked, then it just returns that. If it's unable to resolve, it will attempt to pull out of a given cache. And then we just return either back the cached version or the network version. Oh, sorry, if it's unable to resolve, it'll actually return with a 503 status, service unavailable. But at that point, we can then decide that, sorry, your text message showed up twice. Acknowledge that that I got it. So we can decide to either serve out the cache version or the network version. So this gives us a nice little API for actually caching GET requests and then serving them up in the event of no network connectivity. Can you use it? Can you use this stuff? As I said, all the major browsers, with the exception of Safari, have it shipped. Edge is in development, but this is actually from a few months ago, so it could be a little bit further along. So the obvious missing part right here is Safari. So let's talk about that real quick. So WebKit Nightly, I think just last week or the week before, announced that they have added in the Fetch API. This is a great sign. It's an indicator that Safari is moving in the direction of this because the Fetch API was built specifically for progressive web apps. Furthermore, the progressive web app face-to-face that all major developers of the Chrome, Firefox, Opera, and Edge projects, they get together every, I think, 2 or 3 months, and they discuss some of the problems that they're each seeing and how best to solve these problems. As of the last meeting, Jake Archibald, who's on the Chrome team, he tweeted out the minutes, and the WebKit team had 3 engineers in attendance. So I know that a lot of people tended to poo-poo on Apple, saying, "Oh, Apple will never adopt service workers because this flies in the face of their business model. They're making so much money off of the App Store." And maybe there's something to do that. But from what I've heard is that the WebKit team is more thoughtful than some of the other. I don't mean that in a negative way, but they they're a little bit slower to adopt certain APIs because they really consider the performance impact that these APIs, introducing these APIs have upon the performance of the browser. The Chrome team seems to be the exact opposite. They tend to just dump ideas into Chrome because they want to get as much functionality in there as possible. And we see the effect of that, right? If you've ever run a JS-heavy web application in Chrome and in Safari, undoubtedly it's going to run much faster in Safari. So perhaps in the end, it will be better that the Safari team has taken more time to consider this. Maybe in the end, they will get a note saying, "Don't do this," signed TC. Who knows? But as of today, all signs point in a positive direction. The unfortunate thing, however, is that mobile Safari is not an evergreen browser. Desktop Safari is not an evergreen browser. So unless we're going to get a magical gift to service workers when the next version of iOS comes out in a few weeks, we're likely going to have to wait another year to see it. It'd be awesome, but I really doubt that's going to come out in a point release of iOS. So time will tell. All right, all this to say that I think that progressive web apps are, not that Web 3.0 is a real thing. This is kind of a tongue-in-cheek slide, but I think that they could usher in a new age of the web. There is a ton of opportunity for the web to do as good, if not a better job than native has done. And it's going to take engineers like you sitting in the room to educate and sell these ideas within your organization. I believe, and what I hope to have provided today was a foundation for demonstrating that there are financially advantageous reasons for doing this. There's lots of fun, technical reasons and fun engineering problems to be solved, but as I'm sure many of you have found out, your boss does not necessarily care about those. Your boss is going to care about the bottom line. So if we can prove out through very good and solid data, and I'm not saying these things just because I'm trying to sell you guys on progressive web apps. I'm saying these things because they're true, that there are financial reasons for doing this. I hope that we're going to end up in a better world where we have a much better web experience on mobile. All right, so in conclusion, progressive web apps allow you to compete with native. Progressive web apps will make you more money. Progressive web apps will save you a lot of money. They're easy to get started, and they're very powerful. They can and hopefully will save the mobile web. All right, so again, I'm from Dockyard. We're up in Boston, but I want to briefly just talk about something that we are offering everybody. I know I'm running short on time, but we'll make this very fast. We are doing a new engagement with clients called architectural engagement. There are a lot of people that are adopting Ember that are concerned about whether or not they're building it out properly. That Twitter handle does not exist. @dockyard.com, that's not real. Don't look at that. So anyway, we've done this with some very large companies over the past few months. We come on site for 2 days, we'll do a code review, and then we'll actually run through and get your application on track with best practices, idiomatic Ember. You have very senior engineers, most likely myself, another senior engineer that comes on site and works with you on this. If you're interested in that type of engagement, the product of which is actually a report that is actionable, that will actually put you on track to either upgrading properly or getting over a particular hump. Part of that time is dedicated to a mob programming session where we actually will take some real problems from your application and implement them properly. So if that is a service that's of interest to you, it's a one-time thing. Please email me afterwards. It's just brian@dockyard.com, and we can discuss it further. And because I unfortunately was not able to come down to DC tonight, as Steve mentioned at the beginning, I had something else that came up. I love DC. I actually lived in DC for a while, and little known story, I actually started this meetup years ago. But I'm offering everybody a 15% discount off of the architectural engagement. So if you contact me and said, "Hey Brian, I saw you at the DC Ember meetup. I'm interested in the architectural engagement," we'll offer you a 15% discount on that. So that is my presentation on progressive web apps. Oh, one slide I forgot to include is that we actually have an add-on called Ember Service Worker. And one of our engineers is involved with the service worker story for Ember CLI. So if you're interested in building out service workers, I highly suggest checking out that out. So I guess I can allow, I don't know if there's time for questions or not. I know I'm running short, but Steve, if you want to unmute, or if that's it, you can let me know.
Thanks. Give Brian a round of applause. We're applauding a computer, which is a little weird. Do we have maybe a couple minutes just to see if people have questions? I know we ran pretty late today.
Slides.
Brian, will you be able to share your slides?
Yeah, I have them on. I actually have them uploaded already to Speaker Deck, and I can send those to you.
Okay. Let's actually just maybe on the meetup page we'll email Brian directly those questions. I can also share them with him after. So we'll follow up with you, Brian. Thank you very much.